Sam is working at a space station, and suddenly he has got a data from the main station which says that the current temperature of Mars would go down to log of 1 by 10,000. Now, log of 1 by 10,000 is the data which he needs to send to Mars immediately. But he needs to simplify it before he can send it. So let's see what is the data he got. So he's got log of 1 by 10,000 as a data which he needs to solve. Now 1 by 10,000 is a fraction, and to solve it again we'll get the answer as a decimal. Now finding the log of a decimal without a calculator is really difficult, and Sam doesn't have one. So he quickly contacts Shyam for a quick solution, a better solution, so that he can solve it without a calculator. Now Shyam informs him about the quotient law of logarithms. So the quotient law of logarithms, according to Shyam, is log of x by y can be written as log of x minus log of y when the base is b. So we see that any question in the format of x by y can be written as log x minus log y. But again, Sam has to recheck this, because if he doesn't recheck it and if this is a wrong law, then his equation will be wrong and his data would come as wrong. So he tries to solve this. Again, he would try with some assumptions. So he assumes that x is equal to 4, y is equal to 2, and b is equal to 2. With these assumptions, he solved the LHS and RHS. So we take the LHS and the RHS. So with these values, if we solve this side, what do we get? We get log x by y. That will be 4 by 2 to the base 2. Okay. So solving this, what do we get? Now 4 by 2 is nothing but 2. So it will be log 2 to the base 2. Now if we have this from properties, we know that if the argument and the base is same, the answer is 1. Okay. So we found the LHS value is 1. Now let's solve it for RHS. So here we have log x to the base b, that is log 4 to the base 2 minus log y to the base b would be log 2 to the base 2. So we have log 2 to the base 2. Now again, log 4 to the base 2 is nothing but 4 can be represented as 2 into 2, that is 2 times 2. So this will be 2 minus, again we have the base and the argument is same, so this will be 1. So solving this, we will have 2 minus 1, that is 1. So we have LHS is equal to RHS. That means that this law stands true. So now let's help Sam solve this particular problem. So he has log 1 by 10,000 to the base 10. So this is in this particular format. So we can write it in this particular format. That means log 1 to the base 10 minus log 10,000 to the base 10. So log 1 is always 0, right? So it's 0 minus, now 10,000 has 4 zeros, right? So it will be 10 to the power of 4. That means we have the answer as 4. So 0 minus 4 would be minus 4. So that means that the temperature on Mars on that day is going to be minus 4 degrees C, which he informs to the Mars mission and solves his problem. So let's now see another example. Let's say you have to solve log 80 to the base 4 minus log 5 to the base 4. Now again, here neither 80 nor 5 are a power of 4. So they become a bit difficult to solve without a calculator. But if we apply the quotient law, let's see. Anything written in the form of log x to the base b minus log y to the base b can be written as what? It can be written as log x by y to the base b. So solving in this particular format, we can write this as log 80 by 5 to the base 4. Now, if we divide 80 by 5, what do we get? So if you divide 80 by 5, what would you get? 16. So we have log 16 to the base 4. Now 16 is nothing but 4 into 4. That is 2 times. That means the answer is 2. So you see how this particular complex problems was solved so easily with the help of the quotient law of logarithms. And that is the beauty of quotient law, and you can practice more problems and become more proficient so that you can solve much more complex problems with the help of the quotient law.